As the small opening scenes already indicates, it is about the following initial situation. The module chain was chosen, the sensors have been selected, and what we have to do now is to define and determine the channel names, obtain scaling data for the sensors, pass the settings to the measurement technology and software, test the measurement setup, and document the final setup. That sounds easy. Yeah. For a small measurement setup with a handful of channels, it is. For a small setup, you can type in the scaling factors and channel names by hand or take them from a PDF Excel datasheet. For large measurement setups with tens of sensors and long lists of channel names and their comments, manual inputs may easily lead to errors and will take too much time. Keep in mind, we have quality objective when creating configurations. Quality objectives like accuracy. Think of the dialog at the beginning. Simplifying the work by simply deleting a few digits can mean a loss of accuracy. Have in mind that entering 1.0 instead of 1.01 means 1% change of results accordingly. A number twister, let's say from 1.21 to 1.12, causes already 8% deviation. As a supplier, you sometimes feel like tormented with high demands on precision. Later, you notice customers don't profit by accuracy because a datasheet was used instead of an accurate calibration certificate. Notation. Typically, the workflow of analysis tools is based on channel names, in example, vSignalizer, Diadem, Vamos, or others. An instrumentation template will come to nothing if the name is misspelled. Scripts for automatic evaluation will not find their source channels. A simple case-sensitive error may spoil the evaluation process. Without the description of the setup, only the person in charge knows all the details, and maybe he will remember it for some weeks only. Therefore, use comments to describe the measurement point. Wouldn't it be great if Input Assistant helps you not to forget the comment? Documentation is a point I would like to stress. You will probably know it. The guys from quality management like to put a finger in the wound when documentation is missing. This is not a necessary evil, but it can help to save measurement results. It happened to me personally that the final evaluation of a measurement showed unexpected results. The measurement could not be repeated because the test specimen was no longer available. Thanks to documentation, the sensors could be determined and their setting values checked. Thus, the error could be found and corrected. The test was saved. This does not always work, but without documentation, it works almost never. At this point, we went into depth why it makes sense to work carefully. Now, it's about the methods how to do it, and if possible, to do it quickly for a rapid workflow. In the following slides, I will present our approaches to this. So we will talk about TEDs, sensors, properties are in the plug. We will think about signal databases, which may allow select channels instead of typing and will provide standards for automated evaluation. We will talk about sensor databases to select sensors instead of typing properties and replace TEDs, for example. And we will think about measurement schemes, which allow the preparation of complete sets of signals. So let's start with TEDs. What is TEDs? TEDs stands for Transducer Electronic Datasheet. This means within the cable or the plug, there is a silicon chip which stores the properties of the sensor. It's in a standardized format for IEEE 1451.4. For configuration, the TETS capable hardware can read the scaling, offset, unit, supply, etc. So the parameters, let's say, are wired to the sensor. So if you move the sensor from one input to the next, the input sockets will the data goes with, and the data can no longer be mixed up. The data of the calibration certificate is inside the sensor. Misplacing the certificate can no longer happen. In one go, you can read the data of a whole measurement chain. That's really quick. So I will show you how we do this in CSM config. To do this, I switch to CSM config. Now you see our configuration tool, CSM config, and with buttons to handle our modules. One is this wizard to check for the chain. So you see a list of 3 modules here. It is the THMM, an ADMM, and strain gauge. There's a report, 3 modules found. Here we can open the list of signals, for example, of an ADMM. And here you find the channel name, comments, factor, offset, units, excitation, and all the stuff you need to configure a module. In the beginning, we talked about manual inputs. You can enter, for example, a factor of that manually or just read it using TETS. We have this context menu to read the TETS. When you try to read, you find the property which is in the document and what is in TETS. We simply apply, and the setup of the stored in the TETS is now in my module. You see the unit changed, it's the excitation changed, and you have additional information about the setup. This is the step for one single. Of course, sensor you can read the entire chain in one go, as mentioned. So we just use the context menu on your little bus, click on Read TETS. Now the chain reads the TETS connected to the modules. And after a while, we can click on Apply. We find the note that there are some inputs not connected to TETS sensors. Okay, we accept this, and we are ready. As you can see here for ADMMs, there are some chips displayed close to the signals, and we see they are configured by TETS. What we don't have is configuration of channel names and comments. We have to take care of this in the next step. So what did we learn about our application with TETS? It provides a quick reading of the settings of the active, let's say, ready-to-use chain. Quick is one of the keywords from the input dialog, you might remember. In your planning, you must take into account that you will need a time when it's allowed to power the measuring system. An example for higher voltage application, this may be not possible at all times. The channel name or comment is then taken care of in an additional step. Remember, channel names are not a sensor property, and therefore it's not stored in the sensor. So now 2 questions come to mind. How can I fill in the missing info? I mean, the channel names and the comments. And what can I do if my sensor does not have TETS? Let's check how databases can help. One database I will talk about is the signal database. Database is a big word here. You should not be scared. In fact, a flat table is the simplest form for a database, and it's sufficient. What we intend to do with a signal database is we want to have error prevention. Create the database once and check it without hurry. Afterwards, you can use the entries again and again by a few clicks only. When selecting the signal name, the database can also bring the comment with. This way, you also make something good for the documentation. Standardization of channel names allow selection of prepared lines will avoid great variety of names. Your evaluation team will be pleased. If standardization is arranged as a company-wide standard name system, it even facilitates collaboration of different teams. Central management is the keyword to achieve this collaboration. To give an impression, I will show the implementation with CSM config now. Remember the setup we created so far, which was missing channel names and comments. For channel names, we have this column here, and we find close to the channel name this button with the three dots. I click on this, and this opens the signal database. I can enter, for example, a channel name or just have a look at the list. This list may be pretty long, so sometimes it's useful to type in keywords, for example, pressure, to find pressure sensors. Okay, this one is the one I want to have. I double click, and here the channel name is taken. And the comment was added. That makes it easy. And of course, it is possible to have this comment not only in English, but also in German, for example. This could be helpful if your colleagues coming from abroad. It may help to enter the data. How did we do this? To check this, let's enter the setting dialogs of config. You find in the setup an entry for signal database. We open it, and this is the basis for our signal database. I can open it as you see, it's a CSV. And in Excel, you see it's just a flat table. One column with the channel names, second with comments. Just enter a new line and your channel list is extended. Let's go back to config and back to our slides. You see, databases are known to be complex, but the structure of this example was pretty simple. So we have a small effort with a great benefit. So what did I learn for my application? You see, the signal database and TETs fit together well. The readout was fast, and now you can quickly select the names also. It is no constriction, but effective help, because you can still do changes if it's absolutely necessary. Of course, this is also applicable without TETs. Also, you don't need an active module chain. The signal database does not bring the sensor parameters. That's why we had TETs for. And if you use signal names in the comment in another language, you can even realize something like multilingualism. So finally, the combination of TETs and signal database is clear, but what if my sensor does not have TETs? Sensor database is just an answer for that. And why to use sensor databases? It adopts all parameters of a particular sensor for a channel. It's just like the TETs did in the slides before. So it's a substitute if TETs is not available or the chain is not available. With selection instead of typing, you always have the full accuracy. Being in a hurry will no longer be an excuse for entering fewer decimal places. You might remember from the input dialog. Central storage makes the data available to all users at the same time. Maintaining an entry at a single place helps all users simultaneously. As an example, I will show you the implementation in CSM config. So you see here the setting done with TETs and signal databases. Now let's check how we can do it with sensor databases. So I bring the ADMM back to factory settings. Okay, now there is no setting. And of course, I can apply my single database as I did before, but now I use here the column sensor name to add the appropriate sensor for this. For example, the pressure sensor or temperature sensor, whatever. Again, I have this sensor name list here, and I can filter. And of course, I can combine these filters. For example, I can add CSM here. Yes, only CSM. So combine these filters. I just click here and you see the settings are adopted. How do we do this with the sensor databases? Again, we go to options, settings, and close to the entry signal database. I find the entry sensor database, click on open. Again, you see it's an Excel format. And you see it's a flat list, just a few more parameters. Let's go back to our presentation. With sensor databases, we have some special advantages. Due to the simple structure of the ASCII file, the sensor database can be created and maintained manually. Of course, just type a flat list. But why not using the knowledge of other departments to generate the list automatically? Companies that use many sensors in a wide variety of setups usually have a team carrying of measurement equipment that works together with a calibration service. You could use these services to update the database. Ideally, the process of sensor recalibration also triggers the update of the sensor base, automated without manual intervention. This way, the sensor data is always up to date and for all users simultaneously available if the database is also stored centrally. So the calibration service can contact to administration of sensor tools, and they both export the data they have already in their databases to the sensor database format and the signal database format. And these departments very often have good tools to trace their actions, so its data is always traceable. So the data is up to date for all users. Calibration certificates will no longer be misplaced, and the status of the data is traceable. By the way, this database is can be used offline, means it is not necessary to have a ready-to-use module chain. Hence, it is possible that you use they can be used in the workshop for installation, while at the same time configuration is taking place in the office. And parallel processes accelerate the overall process. So far, we have only talked about configuring individual signals. Isn't it possible to configure entire sets of signals? CSM's approach to this is called a measurement scheme. In short, you find the word MSP. Schemes combine the individual signals of a measurement chain into an overall list. Besides scalings and sensor supply parameters like other parameters like rates, filters, module type, input numbers, and etc. are also included. How does this work in CSM config? Let's explore the structure from the result. So we go again to CSM config, and here in CSM config you find a ready configured module chain. Let's check how it is as a result. in a measurement scheme, we just export this one here. Okay. And now we check it. What you can see is a flat table with different colors, and all these colors describe one channel of a module. You find different channel names. Here the channel names we had, the serial code of the module, whether it's active or not, channel number. So you have an awful long list of parameters which were not available by signal databases or the sensor databases. All these parameters can be used by your tool set to create a list of the entire module chain. And what's very interesting, this one is in ASCII. You can use scripts, for example, to optimize it. Let's go back to summarize what is possible. Many tools and databases from the team caring for sensors and measurement equipment have interfaces to Excel. Following the saying, anyone can do Excel, it should not be too complex to work with measurement schemes. Excel scripts may compile the files with signal lists for the CSV import-export interface of CSM config. For the configuration, it's not important to have the hardware of the measurement chain available. Different teams can work simultaneously on the same configuration task. Team 1 cares of the modules. Team 2 cares of the settings and of the installation of and mounting, and just imports and transfers the setup. Again, automation by script and parallelization of operation can help to speed up the process of configuration. Of course, for a seamless work of teams, you need good documentation. A report should describe all components of this measurement setup in detail. Remember the rescue issue in the beginning of my presentation. So let's show in CSM config how a report is executed. This is our chain we configured. And now let's check how to get a report. To use it, we go to File, click on Report, and this generates an HTML file with the setup. HTML is popular to anyone. You can use any browser to open it. And you find the description of the canvas which was in use, maybe EtherCAT as well. You can have THMM settings, ADMM settings, and even the firmware, the hardware revision, protocol used, serial number, device number, calibration date, the laboratory which did the calibration, all this stuff is given in the list. And very important for the second team who has to mount the modules, channel numbers connected to different sensors are given. For example, channel number 1 of module with the serial code 32861, and so you can easily find the correct input for your sensors. So this is a very complete and complex list of all the parameters used for the set. So finally, let me compare the list of approaches we had. First, we talked about TATS, which had the data in the plug. This provides no signal names, and you can use it online. And the automation is just read out by a module scan of an entire list. The second was signal databases, which know sensor data, but the signal names in lists. You can have it online as well as offline, and central maintenance allows to be up to date. You use it for manual selection. Sensor databases have the sensor data but no signal names, so these two work together well. You can have them again offline as well as online with central maintenance for a manual selection. Measurement schemes um, allow to have the sensor data as well as the signal names, as well as all the other parameters for configuration. You can use them online as well as offline. And if you use external sources, you can have an extensive level of automation via Excel scripts. With this, I'm at the end of my presentation, and I hope I could provide information that will help you. Allow me to conclude with a small quote from the daily business of a customer after the presentation. If I had known this earlier, you would have saved me many hours of work. And I hope I could save you many hours of work with my presentation.